Right, today we'll start a brand new chapter, so we're going to be in chapter 2. Chapter 2 is about linear equations in two variables, but we're not going to worry about that right at the particular moment. We're going to go ahead and look at what we call the Cartesian or the rectangular coordinate system, all right? Because we're going to be graphing lines. We want to make sure we know what the coordinate system is. Now, we have two different number lines for this one. We have our regular one that we've been graphing with, right? That guy right there, right? And it works the same. The positives are on the right, negatives are on the left, and 0 is where these two are going to intersect. Okay, and then we add another one perpendicular to the other number line, and this is what we call our two-dimensional Cartesian or rectangular coordinate system. Okay, so our regular number line, the one we're used to, right, is we're going to call it our x-axis. Right. The other number line that goes up and down, we're going to call the y-axis. Okay. And these two axes go ahead and cut into four pieces, our two-dimensional plane. Right? And we have numbers for the quadrants. They're usually in Roman numerals. So quadrant 1 starts right here, Roman numeral 1. And we go counterclockwise, so against the way a clock runs. So quadrant 2 is over here. Quadrant 3 is over here. And quadrant 4 is over here. Okay. We have a very special point in the center, which we call the origin. Right? And the origin is where the zeros of both number lines meet. Right? If we go ahead and look at our quadrants, this in the middle where the origin is a point we call 0, 0. Okay, so basically it's the zeros of both number lines. If we go ahead and go to the right on the x-axis, these numbers are all positive. If we go to the left on that axis, our numbers are all negative, and then our zeros are in the middle. With the y-axis, as we go up, our numbers are positive. And as we go down, our numbers are negative. And what we use these for is we want to go ahead and be able to plot a point in the area of a two-dimensional plane. So rather than plot it on a number line or plot an interval on a number line, we're now going to go ahead and plot a point in a two-dimensional plane. All right. And we do this through something called an ordered pair. Okay, and I did an example of an ordered pair for the origin, 0, 0. And all ordered pair is it lists your x value for your point first and your y value second. Now this does look like interval notation. It's not. It's completely different. Right, so don't get them mixed up. And what we do with an ordered pair is the first thing we do is we navigate right or left the direction of y, or x, sorry. And we travel either left or right, depending on if it's positive or negative, from the origin. So we always start at the origin. So we start at 0, 0 when we plot points. Okay. And then once we get to our x value, we don't put anything. And then we look at our y value and go up or down from that x value that we already plotted. All right. So basically what's going to happen is each quadrant is going to represent certain things, certain ordered pairs. All right. So if I look at quadrant 1, I see that all my x values are positive and all my y values are positive. So any ordered pair in quadrant 1 is going to contain two positive numbers. If I look at quadrant 2, I see my y is positive, my x is negative, So any ordered pair is going to have a negative x value and a positive y value. And it's going to be in quadrant 2. In quadrant 3, they're both negative. I have a negative x values and negative y values, so any ordered pair in there is going to contain 2 negative numbers. And then if I go ahead and look last at quadrant 4, my x values are positive. My y values are negative, so any ordered pair in quadrant 4 is going to have positive x's and negative y's. Okay? And if I go ahead and look at a ordered pair, I can tell just by looking at it what quadrant it lies in. Now there are also points that can lie right on the x or y axis itself, so it could be sitting right on that axis or right on this axis, and they're not in quadrants, they're on the axes. And then of course you can have something centered at the origin. We're going to plot a few points, and we're going to go ahead and look at how this works and how we travel from left to right as best I can on a digital type of basis here. All right, so here I have a graph already set up, and I have sets of ordered pairs. All right, and what I'm going to do is I'm going to give them letters. Because I want to make sure that I go ahead and I have to label my points. And it's usually easier to do it by putting a letter rather than putting the ordered pair itself. Now I want you to look a little bit at the scaling here. So if I go back to my first graph, notice that every single box in my grid paper has a slash mark. I'm assuming that is by whole numbers, by 1, 2, 3, etc. Sometimes it's good to label a few. But because it's every single box, I can assume that this is 1, this is 2, this is 3, and etc. all the way for each one. Okay? When you look at this graph, notice I skipped every other box. Okay? So you can scale these however you would like. But I also labeled them because of my scaling. So I labeled 1, 2, etc. because I skipped over every other box. Okay? And that's because I know I have to do something else with my graph, and you'll see that in a second. So let's go back to my original numbers here. So my first value is 2, 1. This means my x value is 2. My y value is 1, so that's how I'm traveling. So I need to start from the origin, and I need to travel to 2, but I'm not going to put anything there. From 2, I look at my y value, and I have to go up 1. So I need to go up to where it is 1. This is where I put my point. And I'm going to go ahead and label that point A, or I could label it with my ordered pair. Let's look at the B one. I have an x value of -4, a y value of 3. So I start off from the origin again, and I got to go to -4. But I'm not going to put anything there. Then from -4, I look at my y value, I have to go up 3. Make sure you lined up, and then you put that point. This point is point B. Okay? You don't need to put the little trails that I put. It's just so I can kind of show you, using this device, how to get to that point. Let's go ahead and look at C. C says I need to go from the origin to 5, and I'm going to go ahead and label my 5. So I need to go to my 5, and then my y value is -1, so I got to go down to -1, so I'm actually right here, which is a little awkward with that 5 being there. And this is point C. D should look familiar. It is 0, 0, which means I'm not moving away from the origin on my x, and I'm not moving away from the origin on my y. This is the origin, So I plot the origin, and I call that D. E is an example of something we call an x-intercept. Okay, and you don't need to necessarily know that term now, but no, we're going to be talking about it. E says that I got to go to 1 from the origin on my x-axis, but I'm not traveling at all on my y-axis. That 0 means I'm not moving. So this one is going to lie right on my x-axis. So if I were to ask you what quadrant E is in, it's not in a quadrant, it is on the x-axis. If I go ahead and look at F, this is the opposite. This is a y-intercept, and you're going to be hearing this one a lot more. I'm going to abbreviate it. Okay, this means my x is 0, so I'm not moving away from my origin, but I got to go down to -3. This is my point F. Okay. G and H are not any more difficult than the other ones. All right. The reason why I did my scaling the way it is that I knew that I would have to graph some sort of halves. Okay. So when I go ahead and graph G, my x is 1.5, which means I go ahead, travel to 1, and I purposely have an extra mark in between 1 and 2. I'm going to go to that half mark, but I'm not going to put a dot. That's not a point. Then I need to go up to 2.5. So I'm going to go up from 1.5. Be careful. I got to go up from here. I get to 2, but I got to go up that extra half. This is my point G. And we are going to have an activity where you're going to go ahead and graph things with halves and decimals, okay? Last one I'm going to go ahead and do here is H. H is fractions. That's okay. So if I look at 1/2, okay, that means I got to go on the x-axis just to 1/2. I don't go to 1. Now I have a negative, so I know I'm going down. And I have 3/2. Now this is where you have a few options. I know that 3/2 can be converted to a mixed number 1.5. Or, because I have my graph scaled in halves, I can go down 3 of those halves. So 1/2, 2 halves, 3 halves, and my point will go there. And this is my point H. Okay. Make sure you go ahead, do the practice problems, ask questions if you need to. You may want to go ahead and get some graph paper, or there's usually free printable ones you can print online, or you can create your own graphs. It's good to have a grid to work with, but if you don't, you can kind of create your own graph freehand. And online we can go ahead and talk about that live and show you how to go ahead and create a good graph. But anyway, I will see you guys in the next video. Go ahead and practice.